Hey guys, this is Mrs. Harbin, and we are moving on to Pre-Cal Chapter 4, and this is Lesson 3, all about finding inverse functions. Now, quick note, normally when I make these videos, I use a mouse, and I am writing in the slides with the mouse. I'm doing this one on a laptop with a trackpad, so we will see how that goes when I go to write. If it's not legible, then my apologies right now for that. Our life application for this unit continues to be that you, the student, will be aware of angles in creation. Just as each geometric angle has a precise measurement when properly aligned with the measuring tool, so too the angle that the student's life takes will have a precise direction if he is properly aligned with God's Word. Everything that God has created is created in a way that is orderly and precise, and our lives are to be the same way. And I know from experience, and maybe you know from experience, that when things aren't orderly and we're not properly aligned with God, what God has created for us to do, things can be a little bit chaotic. So we want to make sure that not only are we doing math with accuracy and precision, we want to make sure that we're also living our lives accurately and precisely according to His Word. Our lesson objective for today is that you, the student, will find the inverse of one-to-one functions algebraically and graphically, and determine if two functions are inverse by applying composition. So we're going to do some examples using all of that. First of all, let's talk about what an inverse is. The inverse of a function, which is notated with this f to the -1, that doesn't mean it's being raised to the -1 power, by the way. So this is not taking your function and raising it to the -1 power necessarily. This is our notation here to show that this is the inverse of the function. So the inverse of a function is a relation that results when the first and second coordinates of each ordered pair are interchanged. So the first being our x and the second being our y. So when we flip-flop those x and y coordinates, what we get is an inverse. The inverse relation is a function when the original function is one-to-one. Now, we talked about one-to-one functions earlier. A line can be a function and not be one-to-one. And a good example of that is, let's find the mouse so I can write on the screen here. A good example of that is the quadratic function. We know the quadratic function looks like this lovely parabola shape. It is a function because it does pass the vertical line test. However, it is not a one-to-one function because it does not pass the horizontal line test. So we know that it can be a function without being one-to-one. The inverse relation of a function is one-to-one when the original function is one-to-one, or the inverse is a function when the original function is one-to-one. So if we were to do the inverse of this quadratic function, the inverse would not be a function because the original is not one-to-one. All right, let's take a look at what we mean exactly by this swapping out or flip-flopping our x and our y, or interchanging our first and second coordinates. So take a look at this function. These are some points on our original function. We have 3, 5, 2, 9, -6, 4, 5, and 7. These are x, y coordinates. These are not intervals because we're not talking about intervals right now. We are talking about coordinates. So we've got our x, y coordinates listed there. The way that we can determine a function when we're given a list of coordinates is really just seriously as easy as interchanging them or swapping them out. So our function coordinates would look like this. You can see that what was the x coordinate becomes the y coordinate, and what was the y coordinate becomes the x coordinate. And you can see that for each of these four ordered pairs. So if this is the original function, this is the inverse. So that's one way to find the inverse if you are given a set of points. However, more often than not, you're not going to be given a set of points. What you're going to be given instead is an equation. And so we need to know how to find the inverse algebraically. So the first thing that we want to do is interchange the variables. We want to make sure that when we write our original equation, instead of f of x, let's use y. So write the original equation, the original function, but use y in place of f of x. Then interchange the variables. Wherever there's an x, put a y. Wherever there's a y, put an x. After you've done that, solve for y. And if the inverse is a function, express it using f to the -1x. And we'll know it's a function if our original function was indeed one-to-one. So let's try that. This is our original function. Our original function is f of x equals 5x minus 7. When we think back through our knowledge of the different types of equations, the different types of functions, this is a linear function. Our x is being raised to the first power, and a linear function looks like this. A linear function is 1 to 1, so therefore our inverse will also be a function. The first thing that we want to do, though, is rewrite this using y in place of f of x. So let's go ahead and write y equals f of x. Then we're going to swap or interchange our variables. So I had y equals 5x minus 7, but now I have x equals 5y minus 7. Step 3 is solve for y. So we want to isolate that variable algebraically by adding 7 here. Oh, this may be more difficult than I thought, writing with my finger, adding 7 to both sides. And then the 5 will be with the y. We need to get rid of that 5, so we're going to divide both sides by 5. And when we do that, we get y equals x plus 7 divided by 5. All right, we know that it's a function because our original function was 1 to 1. So now we're just going to replace that y with f of x, or f to the negative 1x. So f to the negative 1x equals 1/5 x plus 7/5. So we're going to break that apart here. 1/5 x plus 7/5. And that is our inverse function. Let's try another example. Let's find the inverse of, oh, we already did this one. Let's find the inverse function rule for f of x equals 5x minus 7. We've already solved for the inverse function here. The inverse function is 1/5 x plus 7/5. If we take a look at that graphically, you'll see that the red line represents our original function, and the blue line represents, the dark blue line represents our inverse, and you'll see that there's a third line there, and this third line has a special name. This third line is called the identity function. It's the line that represents y equals x, and I'll try to write that up here. It's the line that represents y equals x, also known as the identity function. And that line is going to kind of be our point of reflection for inverses. Our original functions will be reflected over that identity line and when we graph this. So here's what I mean. So in our original function, we had a coordinate right here at 1, -2. If we flip those, we should have a coordinate now at -2, 1. -2, 1. Yep. Our original function had a coordinate at, it looks like 2, 3. Okay, so our inverse should have a point at 3, 2. We do, in fact. So this is how we can go about solving a function graphically. We can actually graph the first function, draw our identity function as our line of reflection, and then just start plotting those interchanged points to graph our second line, our inverse line. All right, let's take a look at f composed with the inverse function of f, if f of x equals 5x minus 7. So we need to know two things in a composition. We need to know the equation for the original function, which we do, 5x minus 7. And then we need to know the equation of what it's being composed with. In this case, it's being composed with the inverse. So we need to first find the inverse. So our steps for finding the inverse is to write the original function in terms of y. So y equals 5x minus 7. Once we have written that in terms of y, we're going to swap the x and y. So we get x equals 5y minus 7, and then we solve for y. Now this is the same function that we've seen in the previous two examples, so we already know our inverse. The inverse function is x plus 7 divided by 5. Now remember, in compositions, we're working our way from the inside out. So what we're going to do is take this function and plug it inside of this function wherever we see an x. Here's what that looks like. So we take our inverse function, the inside piece right here, And we're going to plug it into the original function, the outside piece, anywhere we see a y. Or see an x, I'm sorry. So we have 5, and then originally we had an x here, 5x minus 7. But now instead of 5x minus 7, we are going to plug in that inverse function of x plus 7 divided by 5 minus 7. We will then simplify that function, x plus 7 minus 7, which leaves us with just x. Anytime you compose a function with its inverse, you should get that f of x equals x, or y equals x. That's that identity line, x equals y equals x. So that's one way to check if two functions are in fact inverses. Plug one into the other, compose one with the other, and see if you end up with just x. If you do, then you have found two inverse functions. The composition of a function and its inverse, like we just said, is always the identity function, y equals x, x equals y. So I might give you two functions and ask you to show whether they're inverses or not. And you could do that graphically if you wanted, or you could just compose one with the other, see if you get x, and you have a quick answer. The identity function provides a line of reflection that relates the graph of a function and its inverse. And we looked at that previously. That identity function, that x equals y equals x, that's that line that your original function is going to be reflected over. So let's try and find the inverse of a function, not algebraically. Let's assume we don't know the equation of this function, this red line down here. We don't know what's happening. We just have this graph. But we can go ahead and sketch the inverse because of what we know. We know this blue line is our identity function, which is also the line of reflection. We know that our original function is 1 to 1, so that tells us that our inverse will be a function. And we've got y of x sketched here as our guide, as our point of reflection. And then what we can start doing is looking at some specific points and then switching those x and y points in our coordinates and plotting them on the other side. So one of my original points was 0, -1. If I flip-flop those on my inverse, I should have -1, 0. So this should be a point on my inverse here. Another point that I had on my original function was -1, -2. Flip-flop those, and I should have -2, -2, -1. I was going the wrong direction there. Okay, now other points are not quite as clear because they're not exact points of intersection, but we can get pretty close. Like this is pretty close to 4, 0, so I should be pretty close to 0, 4. All right, and then we would connect those dots. It should look like a reflection, and if you remember any lessons you ever learned about symmetry when you were in elementary school, you want to try and make that side symmetrical to the other side. It kind of looks like butterfly wings there if you turn your head to the side. All right, you can see my sketch is not great, but it generally follows that same curve. All right, so today we found the inverse of one-to-one functions algebraically. We did that by swapping our x and our y and solving for y. We found the inverse of one-to-one functions graphically. We drew the original function, we added our identity function as a line of symmetry, and then again flip-flop those points over the line of symmetry to sketch our graph. Plus, we also determined if two functions are inverses by applying composition. Plug one function into the other function. If you get y equals x, then those two equations are in fact functions, or are in fact inverses. If you plug one into the other, if you compose one with the other and you get something totally different, then they're not inverses. So there are all kinds of ways that we can find the inverse and determine if things are inverses. Make sure that you write down any questions you have and save those up to ask me next class.